All right, this is Math 189, Section 1011, Inclusion, Exclusion, Video 5. Here we're going to answer the question, how many integers between 7 and 770 have the form 7 to the u times 11 to the v, where u and v are natural numbers. All right, so and this is inclusive, all right? This is inclusive. I don't mean inclusion, exclusion, just inclusive, meaning that like how many between 7 and 770, including 7 and including 770. That's what I mean by inclusive there. Okay, so what we're going to do is we're going to two sets. We're going to say A1 in this case is multiples of 7 from 7 to 770, inclusive, including 7, including 770. A2 multiples of 11 from 7 to 770, inclusive again. All right, now we're going to use the inclusion-exclusion principle. All right, so our answer is going to be the cardinality of A1 union A2. All right, this is the, think of this is the number, so if you just take away the cardinality for now, just think of this, right? This is all the multiples of 7. This is all the multiples of 11, right? There are some things that are both multiples of 7 and of 11. That's like 77, right? So A1, A2. But if we can count how many is in the union of both of those, then we count however many they are, right? Because we count all the ones that are multiples of 7 but aren't multiples of 11. All the ones that are multiples of 11, not 7, and all the ones that are both multiples of 7 and 11. All right, so if we count that, then we'll get it. Now there's going to be definitely some overcounting, right? Because if we count all the multiples of 7, right? If we just count all the multiples of 7, those in A1, right? Then we're going to, if we count everything in A1, right? Remember this whole thing. If we count all those, then we get all the multiples of 7 and 11 once. And then if we count all those, then we get all the multiples of 7 and 11 again, right? So we're definitely going to need to figure out how many things are in there, how many things are in there, and how many things are in the intersection. Okay? So we got multiples of 7 from 7 to 770. Okay, so let's see. All right, so first thing you could do, all right, the way that I would look at this is, okay, let's first count A1. Let's first count A1. Multiples of 7. All right, so you've got, let's just make a table. Let's say A1, right? Here we've got 7, 14, 21. Now, how far does that go down to, right? 770 is equal to 7 times 11 times 10, right? 7 times 11 times 10. You could think of that as 5 times 2 if you want to. Certainly not a problem. All right, So if we're counting by multiples of 7, right, eventually we're going to get to 770, right? Okay, so this is 1, that's 2, that's 3, right? What goes here, right? What? Okay, and so think about what we're doing here, right? Here we have a function, right? We have a function. Let's give this thing a name over here. Let's say b. Here we have a function f from b to a1. F of n equals 7n. All right, you're saying what is b? B is 1, 2, 3, out to some number, right? What is that thing there, right? So you want to think, okay, how do we get 770? 770 is 7 times 11 times 10. Let's see, 11 and 10, you got 0, that's 110, right? All right, so that's 7 times 110. So that must mean that we have 110 here. 110 here. Right, so, and just think, okay, what's f of 110? That's 7 times 110. 7 times 110. You could do the math. Let's see, it's fine. Let's see. You got 110 and 7. You got 0, 7, and 7. 770. Okay. Right, so this guy right here is 110. Right. So how many? So notice here that we can, the cardinality, it's a one-to-one and onto map from B to A1, right? So the cardinality of A1 must equal the cardinality of B, which is 110. Okay. All right, let's play that same game again. Let's use a set C and A2. Okay, multiples of 11. So we have 11, 22, continuing on until we get down to 770. Right, so we have 1, 2, what goes over to 770? Let's see, f of n equals, so think about what is our function, right? Oh my gosh. All right, good thing you're not here. Whew. All right, 770 we know is 7 times 11 times 10. That's 11 times 70, right? So we go down to 70. So f of n equals 11n, right? Does that make sense? Because f of 1 is 11 times 1, f of 2 is 11 times 2. So f of 70 is 770. So that tells me that A2 is 70. So I've got 70. All right. Okay, now let's do it again. Now we're going to go from D to A1 intersect A2. Okay, A1 to intersect A2, these are multiples of 7 and 11. So multiples of 7 and 11 are multiples of 77. All right, so you have 77. Let's see, 77 times 2, what's that? 14, 14, 15, 154. Let's see, that's 4. Choose 14, 15, okay. So you got 1 goes over there, 2 goes over there, down to all right. So now you might have to think, okay, what's the, all right, of course. Right, so you have 770, right? 770 we said was 7 times 11 times 10, right? So you got 77 times 10. You could probably just see that the answer is 10 there, right? So you have 10 going over to 770. So there's 10 of them. So A1 intersect A2 is 10. So $110 plus 70 minus 10. Let's see, that's 100 plus 70. 170.